Okay, so we're going to do a graphing review, and hopefully this won't take very long because you guys are pretty familiar with the graphing, I believe. We're going to be graphing motion, and we're going to talk about two categories. One category is going to be motion that's not accelerating, and the other category is going to be considering motion that is accelerating. So I'm going to start with motion that's not accelerating. We talked about this last year. These would be objects that are moving in a straight line at a constant speed, or we would say at a constant velocity. If I were to graph the position time graph for an object that's moving at a constant velocity, that graph is going to look like a straight line. And the slope of that graph is going to be the velocity itself. So if an object is moving at a positive velocity, it would have a positive slope. I don't know why this won't turn blue. There we go. If the object was moving backwards with a negative velocity, then that would be a negative slope. The velocity time graph, if I were to plot the velocity time graph is going to be a straight line whose value over here on the axis represents whatever the velocity is. We could also say that the slope of this line is going to be that value right here, if I were trying to link two graphs together. So if something was moving at 7 meters per second, then I would plot straight across 7 meters per second, and up here the slope of this would be 7 meters per second. If something were moving backwards at, say, -3 meters per second, then I would plot down here at -3 meters per second, straight line across, and the slope of my line over here would have to represent a slope of -3. The acceleration time graph for a graph like this, for no acceleration, since there is no acceleration, the acceleration time graph is at all times 0. So it just plots right along the axis, which of course is the slope of these lines, because these lines have a slope of 0, and therefore that's what's plotted on the acceleration time graph. So you can see the slope of the position is velocity, the slope of the velocity is the acceleration. When we're accelerating, things get a little bit trickier. All of a sudden the position's changing, but it's not changing at a constant rate. I mean, it's not, the position's changing and it's speeding, the object is speeding up, so the positions are getting farther and farther away from each other as the time goes on. So when we plot that, that's going to be plotted as a parabola. And when we plot the velocity time graph, if the object is speeding up, the velocity time graph will be plotted as a straight line whose slope is the acceleration. If the object is slowing down, it's plotted as a negatively sloping line whose slope is also the acceleration, but the negative of it, because it's slowing down. So this would be slowing down, and this would be speeding up, more or less. However, what this is slowing down to 0 and then speeding up in the opposite direction is really what that is. So these numbers represent backwards motion. And up here, this is what we call forwards motion. So if an object starts from rest and moves forward, speeding up, that's what his slope is. That's what his graph would be. If he starts positive, moving, and slows down to rest and then turns around and goes back the other way, that's what this would look like. The acceleration time graph for something that's accelerating at a constant acceleration is going to be a straight line. But this time the straight line is a number plotted at the number that represents this slope up here. So if the slope of this was 5 meters per second squared, then you would plot at 5 here, a line straight across. If the slope of this blue line was -2 meters per second squared, then you would go down here to -2, and you'd plot a line straight across. So that's going to represent how these three graphs are related to each other. So you're gonna do an assignment, it's gonna ask you a lot of different questions, ask you to create a whole bunch of graphs, you should be okay with that. You can spend a little time on that, and, we'll check it, we'll go over it tomorrow.